Hello and welcome to 2016 Paper 2, Question 9, Section B. So, as usual, I'll just start the video by saying you should pause this and have a go yourself and see what you come up with. So this is just first look. It's a while since I made up the notes. This is a coordinate geometry question. Okay, it's going to involve coordinate geometry. Now with project maths, or I suppose maths now, the project has dropped off. Anything can come up in any question, so don't be surprised. You've hopefully been familiar with this question by trying it yourself, so let's hope we can just run through it. Now, Joe wants to draw a diagram of his farm. He uses axes and coordinates to plot his farmhouse at the point F on the diagram below. So Joe must have lots of time on his hands. So the plot here shows the point 4 on the X, where that meets the line 1 on the Y, so it's the point 4, 1. So part A, then part 1, okay, asks for the point, okay. So it's the point 4, 1. That's handy. Now, a barn is 5 units directly north of the farmhouse. Plot the point representing the position of the barn on the diagram and label this point B. So we're assuming each unit is represented by 2 boxes, assuming that is the case, and that the north is directly up, south directly down, east, west, whatever. So barn is 5 units north, so 1 unit, 2 units, 3 units, 4 units, 5 units. So that should be point B. Now they say label the point and label it B. Now if you want to put in 4, 6, so the coordinate is 4, 6, you could, don't require it, but sure. Yeah, I'm not sure what to do there because you don't want to over clutter the diagram. I would always say do the stuff in pencil if you can, because if you do make a mistake, pencil you can rub out. With a pen, you'll always see the mistake, and there's only one diagram. So move on to part. Let's see. Now that's the answer. Sorry, the answer to part A. I've B plotted now just for this. The way you would end up seeing this diagram, all the units or the parts, the next few parts are on this diagram as well. So go on to the question B. Joe's quad bike is marked with the point Q on the diagram. Find the distance from the barn B to the quad Q. Give your answer correct to 2 decimal places. So the coordinate geometry, so it's a distance formula. Now, just to point out the tables, those are contents, you're looking here at coordinate geometry. So all the formula you require are here. Okay, you won't need that last one. The one we're specifically focused on right now is the distance formula. I did say length here, not distance, but yeah, hopefully that's not something that's going to stand in our way. Go back here now. So if we look at the diagram, what they're talking about here is from point B to point Q. Okay. And if you thought about it, just as what I'm saying, usually if I was teaching a class, I would have pointed this out before. If I take that triangle there, that's a right angle triangle. Unit 1, 2, 3, 4, 5, 6 units across. Okay. So I could use Pythagoras here. Literally just h squared equals, so hypotenuse squared equals side 1 squared plus side 2 squared. I'll end up with a figure of, what was it? 1 squared plus 6 squared, square root 37 is the answer. Okay. Now square root 37, the calculator should come out to be 6.08. That's an untraditional way of doing it, but it works because if you look here at the formula for distance, that's the same thing as one side, so side A, and that's side B, and you have the square root brought across from the hypotenuse. So the distance formula is a variant of Pythagoras' theorem. Let's go straight to the answer. So I've done it the traditional way here. I've used this formula is designed for use with coordinates. So I've written my 2 coordinates out, Q and B, labeled them first X, first Y, second X, second Y, put them into the formula. Okay, so at this point, fairly far advanced in the question. Now, if you want, you can put the whole thing in the calculator, okay, and go straight to the answer. That's fine. I've done it here just by breaking down, do inside brackets first. So 4 take away negative 2 is the same thing as 4 plus 2, which is 6. So that's what I've done here. In the second bracket, 6 take away 7 is the same thing as negative 1. Then down the squaring, okay, 6 squared is 36. That's what that comes from. Negative 1 squared is the same thing as plus 1. Final step, add the 2 numbers, 36 and 1 is 27. They wanted to not in third form, they wanted it in decimal form, as they've said it. So I've square rooted now. Square root of 37 is a big long decimal that goes on forever. So I wanted two decimal places. Now I've written it to 4 here, but it's the 2 here that's important. So if that number is less than 5 or less than 5, then the previous number stays the same. So I end up with 6.08. Now to cover my proverbial, I won't say, that I put in the word units in. If they told you it was centimeters, fine. They haven't told you any measurement yet. For all you know, it could be kilometers. So you're going to just leave it as units, and then you won't get penalized. That's part B. So then part C here, Joe's tractor is at point T, where FBQT is a parallelogram. Okay, plot T on the diagram and write the quarters of T in the space below. So let's go back and look at the diagram here. Okay, now I added in text there that I'm going to get rid of just to make the situation slightly less complicated. So if we look here, he, forget the scenario. Oh, he left his tractor. So he left his tractor at point T, okay? And that's what would have to happen to make the shape of a parallelogram, okay? Those two sides be of equal length. So technically, you could argue it's just 5 units south of Q. Okay, so 1, 2, 3, 4, 5. Join up to the points, and you have your parallelogram. Now the coordinates there were 2 on the x, sorry, negative 2 on the x, positive 2 on the y. Okay, that's the negative. So let's write that in. So I've done that. So that's part C done. Yeah, that is done. Part D now says Joe wants to plough the land enclosed by the parallelogram, FBQT. Find the area of this parallelogram in square units. Okay, now you have two options here. There is a formula for the area of a parallelogram in the maths tables, okay, and I'll just show that there. We go back to area approximations. No. Where's parallelogram? That's there. Here we are. So parallelogram area equals A times H. Now A being the length of a side, H being you could argue the perpendicular height. Okay. So that's an option. Another option would be to find the area of a triangle. Oh, where's that gone? Okay. Here we are. Okay. Split the shape of the two triangles. Move. This formula will work if one of the vertices of the triangle is on 0, 0. If you move one point to 0, 0, the other 2 points have to move the same distance. So you do translations and then find the area of one triangle, double it to find the area of the parallelogram. It's a bit long-winded. Okay, let's go back to the question here. Now I've done it here. Actually, I've done it both ways. Actually, just to show the two methods. So I'll go through the first method. Now, this is the obvious one to do if you know that formula exists. Okay. So the area is equal to A times perpendicular height. A is 5, perpendicular height is 6. So look at the diagram and see where I'm getting that from. Okay, that A is that's A there. A is your 5 units, okay, and your height up is 6 units. Okay, I've written that down here. So it's kind of looks a bit different than the way it's drawn in the maths tables, but it's still like a valid answer. Put it to the formula and you get an answer. I think it was 30 square units. Okay, so short and sweet. Now, if we do the other method, which I saw a fair few students doing, to be honest, that year, I'm moving one of the points or vertices of the triangle on the corners to 0, 0. So to achieve that, I'm adding 2 to the x value, taking 2 from the y value. Okay. Now, the other 2 points will move the same distance. So 4, 6 moves 2 in the positive direction. So 4 becomes 6. And it moves 2, the y value moves 2 in the negative direction. So 6 take away 2 is 4. So that's one of the points I'm going to use for my formula. I'm moving the other vertices the same distance. So adding 2 to the x value, taking 2 from the y value. Okay, so I end up with the point 6, negative 1. Now, on the diagram here, I've labeled them x1, y1, x2, y2. So I put them through the formula. Now, these bars here don't mean distance. They mean absolute value. They'll turn whatever is in here positive. the idea behind it is that it's an area. You can't have a negative area, but you can have negative numbers appear just by the arithmetic. So you don't want that happening. So you'll turn whatever the negative number here is positive. But let's put the numbers in. So x1 is 6, y2 is -1. To take away, and be very careful here, that's negative. What's it now? X2 is 6, y1 is 4. So I'm just taking those numbers here, being careful, because if you to get distracted, look up and then just put the numbers in the wrong place and things go awry. Do the calculation here. Now, you could program that thing in the calculator, that figure. But we're really saying 6 by -1 is -6. Now you're taking away 6 times 4. So it's -6 take away 24, which is the same thing as -30. Now I'm turning that positive, so half times 30 is 15 square units. Okay. Now that's the area of one triangle, but a parallelogram is made up of 2 triangles, so I'm doubling that. So 15, or I suppose in the first case, not halving it. 2 times 15 is the 30 square units, which is the same thing as the other method. So that's part D. Now we're coming on, we're getting to the end here. That's the last question, isn't it? Yeah. So part E is given that the angle QFB equals 45. So the middle letter here is what matters. Okay. And for simplicity, I've taken a screen grab of the diagram. Now QFB, basically QFB, okay, is the angle here you're talking about. So I've labeled it as 45 here, so for clarity. Okay. No harm you do the same thing. That alone here would get you the attempt, because you've done the correct relevant step. So we're told as examiners to make sure to watch the diagram for labeling, and we do. It's one of these things that it's probably the first thing you'd look for. Given that QFB equals 45 degrees, use trigonometry or trigonometric methods to find the angle BQF. So BQF, this other angle here. Okay. Give your answer in degrees correct to 1 decimal place. Well, first thing I look at, okay, the shape I'm dealing with here is a triangle. It's not right angled. Okay, so Pythagoras and sine cos tan will not come into play. So it's going to be either the sine rule or the cosine rule. Okay, and it doesn't really matter which. I prefer the sine rule in one sense. But I'm looking at maybe trying to draw this out. Now, I've brought the screen grab in, so I have it right here. I'm not going to have space to be messing with it too much. And I have, actually, maybe no harm. Okay, just for the explanation part. So now, rough and ready. So you have your 6.08. Okay, that's one side. You have your 5 here, and you have your 45. And I'm looking for this. Okay. So, would the cosine rule work? Okay, now for the cosine rule to work, I'd have to know these 2 sides and the side opposite. Now then I have to do a rearrange of cosine rule to find the angle. That's a pretty advanced question, okay? Here, what I'm looking at is, I would always just start my problem solving with, will the sine rule work? Okay, now for the sine rule to work, I have to have an angle, its corresponding side, and compare that to another angle and its corresponding side. If I know 3 of the 4 things, I can find the missing thing. In this scenario, I know the angle on the side here. I know the side, but I don't know the angle. So when I do use the sine rule, I can. There's only one unknown, and when I do, I'll find that angle. Okay, so that's the gist of that. Just come through and do it. I have my formula written out. I've put in my angle. Now, I don't need to call that BQF. I could say calling it sine A. I'm just putting it so you know what I'm talking about. Equals, divided by 5 equals sine 45 divided by 6.08. Now, I'm doing a bit of complicated stuff here. I'm doing 2 steps in one, but I'm bringing the 5 across the equal. Now, when 5 goes across the equal, it's divided on the left. What comes across becomes multiplied on the right. It becomes just the opposite operator. Now, that's fine. I could work all that out, but I'd probably get a decimal. And if I left it on the screen and then did the inverse sign of that, it'd be fine. But most people then abbreviate, or they shorten the decimal they'll get, and they end up getting the inverse sign of that, which makes a slightly different answer, and you lose marks for early rounding. I would always leave my things and only put it to the calculator at the very end. Okay, so we left off here when we brought the 5 across. Now I've done 2 steps in one here. I've also brought the sign across. Now when you bring sign across an equal, it changes to its opposite, which is inverse sign. Now you're getting inverse sign of everything on the far side. That's why I have these big, huge brackets. Now, inverse sign of that complicated, I suppose, sum there, it's perfectly typable and programmable into your calculator. So let the calculator carry the heavy labor. Once you press equal, you come to an answer, 35.6, and that's already correct to 1 decimal place. Job done. So that's the end of question 9. So in a few days, have a look back at that and try the questions again yourself. If you're still stuck and can't problem solve it, just have a quick watch the video or just look at the answer in the notes and see if that'll help you. Once you turn the tap on in terms of figuring something out, if you see that again, you have a fairly good chance of doing it again. If you don't ever make that jump and that leap of understanding, when you sit this exam in May or June, whatever, you're going to still be in the same situation as you are right now. So the problem solving yourself, as annoying as it is and as frustrating sometimes it is, it's vitally important. Okay, I can't stress that enough. So I'll probably say it to you repeatedly. Anyway, that's it for this now. So that's the end of 2016 paper 2. See you on the flip side.